Hello everyone, you're welcome to provide a solution given this nice Math Olympiad problem, which is 16 to the power x plus 4x, this is equal to 3. So what is the value of x? Now solution from here, we have 16 to the power x plus 4x, this is equal to 3. We can express 16 here as 2 to the power 4. So substituting this, we have 2 to the power 4 multiplied by x plus 4x, this is equal to 3. So 2 to the power 4 times x, this is in the form of a to the power n raised to the power m, which you can express as a to the power n multiplied by m. Applying this exponent property, then 2 to the power 4 multiplied by x becomes 2 to the power 4x plus 4x, this is equal to 3. The next step here, we just say let 4x being given as m. Now substituting 4x with m, then we'll have 2 to the power m plus m, this is equal to 3. The next step here, let's take m on the right hand side so that we'll have 2 to the power m, this is equal to 3, subtract m. So let's divide both signs by 2 to the power m by 2 to the power m. So let's simplify here. So this is the same thing as 1 is equal to 3 subtract m divided by 2 to the power m. Now, if we have 1 over a to the power n, this can be expressed as a to the power negative n. So let's apply this property from here, so that now applying this exponent property, then we'll have, this is the same thing as 3 subtract m multiplied by 2 to the power negative m, this is equal to 1. Okay, now the next step here, let's multiply both signs here. You can see here we have negative m, we have 2 to the power negative m. So let's multiply both signs by 2 to the power 3. Let's multiply both signs by 2 to the power 3. So on the right hand side, you have 1 times 2 to the power 3. The next step here, if you have a to the power negative n multiplied by a to the power m, this can be expressed as a to the power m minus m. So applying this exponent property from here, we'll have 3 subtract m multiplied by 2 to the power 3 subtract m, this is equal to 2 to the power 3. So as you can see here, the coefficient here, 3 minus m, is the same to with what we have here, 3 minus m. The next step here, if we apply the exponent property, e to the power of natural log of a, this is the same thing as a. So that implies that e to the power of natural log of 2, this is the same thing as 2. So let's substitute this. So where we have 2, let's substitute with exponent e to the power of natural log of 2. So we'll have 3 subtract m multiplied by e to the power of natural log of 2, okay, multiplied by 3 minus m, this is equal to 2 to the power 3. Let's proceed from here. So given that a to the power n raised to the power m, this can be expressed as a to the power m times n. So here we have 3 minus m. Now applying this exponent property, we'll have 3 minus m multiplied by e to the power of 3 minus m, okay, multiplied by natural log of 2. This is equal to 2 to the power 3, which is equal to 8. The next step here, Let's multiply both signs by natural log of 2. So we'll have 3 minus m multiplying by natural log of 2 multiplying by e to the power of 3 minus m multiplying by the natural log of 2. This is equal to 8 multiplying by natural log of 2. Okay, so the next step here, we have 3 subtract m multiplying by the natural log of 2 multiplying by e to the power of 3 minus m multiplying by natural log of 2. This is equal to, now we can express 8. 8 can be expressed as 4 times 2. So this is the same thing as 4 multiplying by 2 natural log of 2. But now this 2 is the power here. Now if you have a natural log of m, this can be expressed as natural log of m to power a. So applying this property, then it follows that here we'll have, on the left hand side we'll have 3 minus m natural log of 2 multiplying by e to the power of 3 minus m natural log of 2. This is equal to 4 multiplying by natural log of 2 to power 2. So let's proceed from here. Now here we have 3 minus m natural log of 2 multiplying by exponent e to the power of 3 minus m multiplying by natural log of 2. This is on the left hand side, and on the right hand side we have 4 multiplying by natural log of 2 squared. Now from here we have 3 minus m multiplying by natural log of 2 multiplying by exponent e to the power of 3 minus m multiplying by natural log of 2. This is equal to, now from what we have here, this is 4 natural log of 4. Now on the right hand side we can apply the exponent property, that is e to the power of natural log of a. This is the same thing as a. Now e to the power of natural log of 4, this is the same thing as 4. So let's apply this, let's substitute this with what we have here. So on the left hand side we have 3 minus m multiplying by natural log of 2 multiplying by the exponent e raised to power 3 minus m multiplying by natural log of 2. So this is equal to, now here we have natural log of 4 multiplying by e to the power of natural log of 4. The next step here, according to rampant, that is rampant W function, according to the rampant W function, you find that the W function of a multiplying by e to the power of a, this is the same thing as a. Now, applying this property, you find that the W function of 3 minus m natural log of 2 multiplying by e to the power of 3 minus m natural log of 2, okay, close the bracket here. This is equal to the W function of natural log of 4 multiplying by e to the power of natural log of 4. Okay, so I hope you're following. If it is your first time, just subscribe. Take 1 second to subscribe. So let's proceed. So applying this W function here, so this part here, this is a, and on top here this is also a. Here we have natural log of 4 is equal to the natural log of 4 here, so this is the same thing as a, and also here this is the same thing as a. So that implies that on the left hand side we have 3 minus m natural log of 2. This is equal to, here we have natural log of 4. The next step from here, we have 3 minus m natural log of 2. This is equal to, we can express this as natural log of 4 can be expressed as 2 to the power 2. Okay, so here if you have natural log of 8 to the power n, this can be expressed as n natural log of a. So applying this property, then here we have 3 minus m multiplying by natural log of 2. This is equal to 2 natural log of 2. So this implies that natural log of 2 and natural log of 2 here simplifies here, so that we'll have 3 minus m. This is equal to 2. So let's take 3 on the right hand side, so that here we'll have minus m. This is equal to 2, subtract 3. So that now here we have negative m is equal to 2 minus 3. This is equal to negative 1. So divide by negative on both sides, so that now m is equal to 1. M here is equal to, so we have m equal to 1. Now if you recall, we insist that let 4x be equal to m. Okay, from what you have here, let 4x be equal to m. Now substituting the value of m here, which is 1, then we'll have 4x, this is equal to 1. Let's divide both sides by 4, so that now here the value of x is equal to 1 over 4. So this is the value of x. This is the value of x. So let's verify that this value of x actually satisfies the equation. Now again, if you recall, we end at 16 to the power x plus 4x. This should give us a value of 3. So let's substitute the value of x here. So we have 16 to the power of 1 over 4 plus 4 multiplied by x, which is 1 over 4. This should give us a value of 3. We can express 16 as 2 to the power 4. 2 to the power 4. So substituting this, we'll have 2 to the power 4 multiplied by 1 over 4 plus, now here we have 4 times 1 over 4. This one simplifies, so this is 1. This should give us a value of 3. So again here, let's simplify here. This 4 and 4 simplifies, so that we remain with 2. So this means we have 2 here plus 1. This should give us a value of 3. So 2 plus 1, this is 3. And this implies that the left-hand side is equal to the right-hand side. And that shows that the value of x, which is equal to 1 over 4, actually satisfies the equation. So kindly follow the steps. Like this video, and subscribe. See you in the next video. Bye bye.